And what's another name for the Z?
Normal.
Normal. So I can type in, and I start typing in normal. Okay? And I get a whole list of things here. Okay? Now, am I trying to get a Z value, or am I trying to get a probability? A probability. So I'm going to sort of looking at, I can't remember that. The p-value is a probability. So if I click on, and normally when I'm doing this, it's going to be one of these two, norm S distribution or norm S inverse. Okay? Now, if I click on here, what does it say? It says returns the distribution. So this returns the Z value. If I click on this box, okay, it says returns the inverse and what I need to do. So I always have to click on these. I always forget which one I want. I forget whether I want to. So it says here that I have to enter what? A Z-score. The Z-score is the calculated test statistic. We call it, I mean, depending on what we're doing, whether we're working with means, proportions, whatever, we'll start working with chi-squares in about a week. So it's always a calculated test statistic, whether I'm dealing with proportions, means, or whatever. So in this particular case, what was the calculated test statistic? 0.884. So I click on that. And I'm either going to type in false or true or false. I actually think I want true. And you see that it gives me a p-value of 0.1883, which is a little bit different than 1894. So see, the technology gives me a p-value that's slightly different than the one I look up in the table. Because when I look it up in the table, I'm only using a Z that has 2 decimal places, right? Where here, I'm actually using all 5 or 6 decimal places, so I get a little bit more accurate value. So if you're only off by a little bit, it's gonna happen. Whether you get it by technology or table. So there's my p-value. But I still have to make a decision. And I make the decision in one of 2 ways. Anybody remember what 2 comparisons I do?
Accept or reject. Okay.
I have a calculated test statistic that I compare to what?
Table alpha.
A table value. And at the calculated test, and when I'm dealing with these, I look at absolute values. And if the absolute value of the calculated test statistic is greater than the table value, I reject the null hypothesis. Well, if I go back here, I have a calculated test statistic. So if I want to compare that, I have to compare it to a table value. Why isn't there anything in there? Okay. This is the wrong label. This is p-value. Table. And this is p-value from Excel. So I need a table value. How do I get my table value? The table value comes from using, how do I get a table value?
The T table.
No, the test statistic is what I calculated. Okay, I need something to compare that to.
The T table?
I'm going to compare it to a value from, what table are we using? The Z table or the normal table.
I mean, yeah, the Z table.
So I'm going to compare it to a value from that table. What is my probability if I look at my picture? If I look at my picture, see, this is my table value. What value goes here? Well, what goes here? No.
The,
What's in my tail?
the 0.05.
What is that from?
Alpha.
Alpha. There's my alpha, 0.05. So I want to know the value on the Z table, that 5% is to the left and 95% is to the right. So if I go back and I look that up in my Z table, that means I want 0.05, so I look at that, and there's my old friend, negative 1.645. So there's my table value. So I'm going to reject my null hypothesis if what?
If the table value is bigger, no.
If
Wait,
the
wait.
calculated test,
If the
if the
p
absolute value.
Yeah, if the P value is bigger than the alpha, right?
Okay. No, okay. I mean, if I'm talking about the test statistic.
Test
So if I calculated that, the calculated test statistic was probably somewhere back here, negative 0.88, right? So where is it at? It's in the meat of the table. So would I expect, would that be an unusual circumstance? No, it is not in the tail.
Yeah.
So based on this information, what would I say about the null hypothesis?
That it's right.
There
Or
is,
Oh, that we do not reject the null hypothesis.
well, no, I gave you some verbiage.
Oh,
There is not
enough evidence?
sufficient, what's sufficient? What type of evidence? What is this class?
Statistics. Evidence.
To what? There's not enough sufficient statistical evidence to do what?
accept the
To
reject the null hypothesis.
reject the null hypothesis that town A is less depressed, or there is not enough statistical evidence to reject the null hypothesis that the town is any different. So I cannot say this town is happier. The 0.5 is basically the same as the 0.73. Statistically, they are the same. There is no evidence to reject the null hypothesis. Therefore, town A is just as depressed as every other town in the nation.
All that.
Especially now.
This will be town A money.
So I do not reject the null hypothesis.
But wouldn't that mean that it is lower if we don't reject it?
No, because we said that they're equal. If we're not rejecting it, we're agreeing that, because remember, the null hypothesis says that that it's equal. That our P prime is equal to 0.73. They're just saying that statistically, there's no difference between them. So that they are equal. If I can't reject the null hypothesis, I'm saying that they are the same.
But the answer for mine, it might be different for yours, came out that there is sufficient evidence to conclude that the proportion of people in the town with depression or depressive illness is lower than the 0.106. So mine said there was sufficient evidence to conclude. Exhibition at the 5% level of significance. What is that supposed to mean? Because mine came out to 0.1210. So if that 0.1210 is more than the 5%, then that means there's enough evidence, right?
Okay. It's a calculated test statistic. Here's my table value, negative 1.645. Okay? So if it's there, my calculated value was here, negative 0.88. So it's not in the table, so I cannot reject the null hypothesis. So I actually, okay, in this particular case,
Do not reject the null
Okay.
hypothesis.
here I said that if the absolute value is greater than this. So the question is here, is 0.88 greater than 1.645? So this is not greater. So I do not reject.
Is greater than the table value.
Okay? I can always state this backwards, where I can say,
Huh?
if the calculated test statistic is less than the table value, then I do not reject HO. I don't care which way you say it, but I have to compare the two. And I have a terrible time remembering it. I plot it. If it's in the tail, I reject it. If it's in the body, I do not. That's basically, I always draw this picture, no matter what. I will draw this picture. If I'm in here, then I do not reject. If I'm out here, I reject.
Okay, the
Now, the other way of doing that is I can compare the p-value and the alpha. And it's just the opposite. Because if I have a number out here, is my p-value going to be big or small? The farther I go out into the tail, is my p-value large or small?
Okay,
Guess again.
Small.
small.
Because remember out here, the p-value is what? The probability? And as I go farther and farther away, my probability gets smaller and smaller. So if my p-value is less than my alpha, I reject the null hypothesis.
Right, okay. Okay, so we could look at it that way, if my p-value is less.
Yeah, I'm either going to, but I have to get a
Less
table, I have to get a test statistic to get a p-value.
Yeah, I find that easier to understand the p-value, because I'm still not sure, okay, calculated test statistic is whatever my z-score is, pretty much, or my t.
And then you gotta use, but see, you can't get, if you don't do that, you can't get a p-value,
Right, I get that.
okay?
But what is the table value? I
The
don't-
table value is the value that's related to the alpha that you want. See, this is the table value that gives you 5% in the tail and 95% in the thing.
The table value is the same thing as the
It-
z-score, though.
It
then.
is the z-score. Where
So
the z-score at which I will decide whether or not I'm too,
But the
the z-score related to the percentage.
But I thought the z-score was the calculated test statistic.
No.
That's why I'm getting
They're
confused.
two different, I gotta compare them.
Okay, so, when I did the calculated test statistics, you said that's the p prime minus the p divided by the standard deviation, which gave me the z-score for me to look up what the
P-value is.
p-value was. Okay, so to me, that's the z-score then, the negative
but-
1.17 I got?
But see, the table, this negative 1.645,
That's what you
it's
got?
the z value at which my alpha, I have 5% in my tail.
5.
Okay.
For my alpha.
It's from the alpha. It's the table value I get based on my alpha.
Because my alpha is
It's
0.05.
So see, I have, this is my alpha, which is 0.05.
Which would be 1.
So see, this is the value
0.645.
where 5% is in my tail and everything else is in here.
Got it.
See, that's why when I compare the two, and see, I always have a hard time remembering, do I reject? I can't, if you just give me the thing and say, here the two values are, which one's bigger, do I reject or not? I'm going to be dumbfounded. I'm going to plot them,
Okay.
okay? And then see here, but the farther I go out here, so the bigger, the smaller my p-value is compared to alpha. So if I have a small p-value, that means that my calculated test statistic is out here. So let's look at which other one do you want to look at?
I think I think it was the next one.
So a particular brand of tires claims that its select tires average 50,000 miles before they need replaced. This is the next question.
The
So
only
the-
thing I couldn't get was the last part, the I, the last.
Okay, but see, it all builds. I can't
Right,
I can't do the last part without doing all the other parts.
Right.
So I'm going to look at this. So is this a means test or a proportions test? Mean, and we know that because it talks about averages. Okay. So I'm going to come down here. So I'm doing a means test. Couple of things that I'm looking at. I have my N. Okay? I have my sample mean. I have my population mean. I also, well, I'm actually going to do this. I'm going to pull this down. And I also have a sample standard deviation. Which means I may or may not have a population standard deviation. I may or may not have this. I don't know. I gotta go back and look at my information. So what does it tell me? It says, from past studies, the standard deviation is known to be 8,000 miles. So does that mean I know my standard deviation or do not know my standard deviation?
You know it.
I know it. It tells, so it says, from past history, I know that this standard deviation of the population is 8,000 miles. Okay? And the population mean is what? They claim is what? How many miles do they claim their tires get?
Oh, 50,000.
50,000. Okay? Now, my question is what? Is that it is what? Consistent with the claim. Average is at least, okay, so here's the trick here. It says what? At least 50,000 miles. And again, this is where I always say, it's normal. I normally go to my alternative hypothesis first. So I want to say that my alternative, it says at least, is what? 50,000 miles? Okay, so I'm looking at this problem and saying, are these basically equal? So because if it's at least, that's saying that it's what? Greater than or, well, see, and what's wrong with this is that this is, I can't have an equal statement. Okay. At least greater than or equal to 50,000. Huh? The sample, so my sample size was what? 30. My sample mean was what? 46.5. And my sample standard deviation was 9,800. Trying to think of how I would word this question. The mean lifespan is 46,500. So what I sort of want to know is this 50,000 or not? Or is this less than 50,000? Are they lying to me? Is it false advertisement? This is where you go in and you start doing things with like cereal boxes and they say there's 13 ounces in the cereal box. If it's consistently less than 13 ounces, they can get sued. Because that's false presenting a false picture. So in this particular case, the alternative hypothesis
Is correct.
is going to be less than, that this is less than 50,000. Because I'm probably sitting there saying, hey, I took a sample, this is less than that. And the null hypothesis is going to be equal to or greater than, because it says at least, right? And the null hypothesis always has to have an equal statement in it. Every time. Part C. State in words what it means. So the random variable that I'm talking about is the mean. So X bar represents the average lifespan in miles. I'm going to be using what table? The normal table. Why?
Because we know
Because we know what?
the standard deviation.
Of population. I have this, so I'm using a normal table. The mean is 50,000. What goes here?
What goes where?
The mean
Oh,
is
yeah.
50,000, what goes here?
The SE, right?
The standard
error.
I call it standard error. They use the little signal with the X bar in there. So what is that?
The square root of the sample deviation.
Close.
Sample deviation over the square root of n.
Not the sample deviation.
I mean, that's the population.
Population
the standard
deviation
The standard
over the
deviation
square root of
of
n. So in this particular case, it would be 8,000 divided by the square root of 30. So my n is 30, there's my sample mean, there's my sample standard deviation, my population mean. So my HO, we already got that, I'm not going to write that on this particular area. So now I need to get my calculated test statistic. So what's my calculated test statistic?
the calculated test statistic.
Something minus something?
The S of the OX, no, isn't that this one? The X bar minus the mean over the
The
standard
mean of the
deviation.
sample minus the mean of the population divided by
The
standard error. See, again, last time we were talking about proportions, so we had P prime minus P. This time we're talking about means, so we take X bar minus mu. And the mu is what we think of the population. So my calculated test statistic. And I gotta be careful, I gotta make sure that I use parentheses.
The mean of
So I'm going to take the sample mean
divided by the standard
minus the mean divided by the standard error. Whoops, I don't have standard error, do I? Not yet. So I'm going to click on this box right here. P103. And I'm going to sit there and say, I want my standard error.
Standard error. And that's the one, the standard deviation divided by the square root of the count.
The standard deviation of what? Of the
The
population divided by the square root of n. So there's my standard error, and now I have a calculated test statistic, which means I can get a p-value.
Okay, I must have done something wrong. Standard.
Did you put parentheses in?
Ah,
Was that it?
yep. Oh man, I'm gonna just have to put a note to myself. Don't forget parentheses.
If you keep doing that, do it in 2 steps. Don't do it in 1 step. Do your mean minus your mu, get that answer, divide that by whatever, and then do it in 3 steps instead of 2 steps. So I can get a p-value. To get a p-value, what am I going to do? And I can do p-values how many different ways? I can get it from the table, or I can get a p-value from where? Will they be the same? Most likely not. So how do I get the p-value from the table?
2, 6. 0.0.
I'm using what table? I'm using the normal table. Now, it's easier to get a p-value from the normal table than the t-table. It's hard to get a p-value from the t-table. That's one reason I don't compare p-values very often. I can almost tell you that based on the